Page 15 of complex numbers and polynomials. Number 1, find the constant k and hence factorize the polynomial if 2x cubed plus x squared plus kx minus 4 has the factor x plus 2. Okay, so if we know that x plus 2 is a factor of this, then we know also that if we take k equals -2 and we substitute it in to the polynomial, that we'll get 0, right? So if we put -2 cubed plus -2 squared plus k times -2, oh, I'm sorry, this is very confusing that I used k in both places. So let's put a equals -2, a being the 0. Okay, so if we put a equals -2 in for the x value, then we should get 0. So that means that -2 cubed is -8, so this would be -16. -2 squared is 4. Minus 2k minus 4 equals 0. Minus 4 and positive 4 cancel out, so -16 minus 2k equals 0. 2k equals -16. k equals -8. Okay, all right, so now we know k equals -8. So that makes it a little bit easier to factorize the polynomial, especially since we know that one of the factors is -2. So let's use synthetic division, and we'll put the, coefficients here across the top. 2, 1, k, which is -8, and -4. And we know we didn't skip any powers here, 3, 2, 1, 0, so it's fine. We don't need to save any space here. And so we'll put first 2 down here, multiply 2 times -2, we get -4. Add them together, get -3. -2 times -3 gives you +6. -2, -2 times -2 is 4, and 0. So our new polynomial after we factor out x plus 2 is 2x squared minus 3x minus 2. This we can factorize just with, guessing. So let's see if we have 1, 2. Does that work? I think it does. So let's put negative there and positive here. Does that work? Yes. So 1x minus 4x gives us the middle term. 1 times -2 gives us the last term. 2x times x gives us the first term. Yes, so it works. So those are the two of the factors, and the other factor that they gave us, which is x plus 2. So this is, they wanted us to factorize, right? Yeah, we factorized the polynomial. There's the factorized polynomial. And we found the constant k. It's -8. 3a. Suppose 3 is a 0 of that polynomial. Find the possible values of k and all corresponding zeros of p. Okay, so if we know that 3 is a 0 of this polynomial, if we plug in 3, then it should give us 0. So p of 3 is equal to 3 cubed minus 3 squared plus k minus 5 times 3 plus k squared minus 7. That should equal 0. Okay, now let's solve. So 27 minus 9 plus 3k minus 15 plus k squared minus 7 equals 0. So let's reorder k squared plus 3k. So we got rid of that, we got rid of that. Let's add all the other factors together. All the terms together. 27 minus 9 is 18. 18 minus 15 is 3. 3 minus 7 is -4. So this could be k plus 4, k minus 1. So 4k, yes, that gives us the middle term, that gives us the last term and the first term, so it works out. So what else do we need to know? So k could be -4 or 1. And it says to find all the corresponding zeros. Okay, so let's say if k is negative 4, what does this become? So if k is negative 4, then we would have z cubed minus z squared minus 9z, and negative 4 squared is 16 minus 7, which is plus 9. So that's a possible polynomial, that one there. And then the other possible polynomial would be z cubed minus z squared minus 4z, because it would be 1 minus 5. And then 1 squared minus 7 would be negative 6. Okay, and so let's see. All the possible, yeah, and all the corresponding zeros. Okay, and we know that one of the, let's see, put that there. Let's do synthetic division on the first one. So we'll have 1, negative 1, negative 9, and 9. And we know that one of the roots is 3. So we'll put that there. And we'll find out what the remaining polynomial is here. So 1, 3, 2, 6, negative 3, negative 9, 0, of course. So one of the remaining quadratics is z squared plus 2z minus 3. So that would be z plus 3, z minus 1. All right? Yes, it is. So for this polynomial, all the corresponding zeros. So for this polynomial, we would have as zeros negative 3, positive 1, and negative 4. Okay, which we got from here, right? And that would be one of the solutions. Let's make this a little bit smaller. Okay, and now let's do the other solution. The other solution would be, put 3 again, because we know that 3 is one of the roots. Okay, bring down the 1, 3, add those together, get 2, multiply by 3, get 6, add those together, get 2, multiply by 3, you get 6, and of course 0 here. So the second quadratic we get would be z squared plus 2z plus 2, and this would be z, now this would not be, we'd have to use quadratic formula for this one. So negative 2 plus or minus square root of b squared minus 4 times a times c divided by 2. So that would be negative 1 plus or minus 4 minus 8, which would be negative 4, 2 square root of negative 4, which would be plus or minus 2i divided by 2, which is I. So there's two zeros, which are negative 1 plus or minus I. And then there's also 3, which is one of the, is it 3 or negative 3? 3. I'm sorry, I put negative 4 here. This should be 3, right? And this should be 3 and negative 1 plus I and negative 1 minus I, right? So this is one of the sets of zeros, and this is the other set of zeros. Let's look at 5a. Prove that x plus 1 is a factor of x to the n plus 1 and is a integer if and only if n is odd. Okay. Okay, so if p is equal to x to the n plus 1, x to the n plus 1, and the remainder, or if x plus 1 is a factor of that, then if k is equal to negative 1, then p of k is equal to 0. Okay, if k is a factor, or k is a 0. So I'm going to put that p of negative 1 is equal to negative 1 to the n plus 1 is equal to 0. And let's see when this is true. we'll put negative 1 to the n equals negative 1. So this only happens when n is odd, right? Okay, yes, so it seems to be true. Okay, so we've shown this direction is true. If we're going to show if and only if, we need to show the other direction is true too. So let's start out with that if n is odd, that negative 1 to the n is equal to negative 1, right? As long as you have an odd n, negative 1 to the nth power is equal to negative 1, right? Then we could add 1 to both sides and we get that. And so now we can kind of like go in the reverse direction, right? We have this, so we could say that if the polynomial x to the n plus 1 with n odd, then if we put in negative 1 there, we get 0, and that implies that x plus 1 is a factor of the polynomial, is a factor of that polynomial, right? We just went in a reverse direction. Okay. B, find the real number a such that this is a factor of this. Okay, so we know that if this is a 0 of this, then we could plug it in and set it equal to 0. So let's see if that works. So probability, or I'm sorry, this is a factor. So the value that we're going to plug in is actually 1 plus a, right? So we're going to put 1 plus a here, and then we'll put 1 plus a cubed minus 3, 3a 1 plus a minus 9. So it'll be 1, and now we're going to do Pascal's triangle. 3a plus 3a squared plus a cubed minus 3a minus 3a squared minus 9. So these two cancel out, and these two cancel out, and we're left with negative 8. We add those two together, plus a cubed, which is equal to 0. So that's equal to a cubed equals 8. So a is equal to 2.